When installing raceways, including troughs, it's essential to understand and adhere to pull box sizing rules. According to the 2020 National Electrical Code, Article 314.28a, where conductors enter a raceway, the raceway shall be provided with a box, fitting, or other means to protect the wires from abrasion and to provide access for pulling or servicing. This means that a trough, being a type of raceway, must comply with the requirements for pull boxes. Pull box sizing is primarily determined by the number and size of conductors entering the box. The 2020 National Electrical Code Table 314.16b offers guidelines for minimum pull box sizes based on the number of conductors. Let's consider a scenario with two 4-inch pipes entering a trough. According to Table 314.16b, a pull box with two 4-inch pipes typically requires a minimum size of 18 inches by 18 inches by 6 inches. However, there's an exception to consider. If the trough is mounted to the bottom of a distribution panel, you might be able to use a smaller pull box. Article 314.29 of the 2020 National Electrical Code addresses this, allowing for a smaller pull box if the conductors are terminated in a cabinet or enclosure. In situations where the conductors from the two 4-inch pipes are terminated within the distribution panel, a pull box smaller than the minimum size specified in Table 314.16b might be permissible. To determine the appropriate size for the pull box in such cases, it's crucial to consult with your local electrical inspector. They can assess the specific installation and provide guidance based on local regulations and interpretations of the National Electrical Code. Now let's delve a bit deeper into the factors influencing pull box sizing. Firstly, consider the conductor size and quantity. Larger conductors and a greater number of conductors necessitate larger pull boxes to accommodate bending radii and heat dissipation. Secondly, examine the conduit size and configuration. The size and arrangement of conduits entering the pull box impact the required space for proper conductor management. Thirdly, evaluate the bending space requirements. The 2020 National Electrical Code mandates minimum bending space for conductors within pull boxes to prevent damage and ensure safe installation. Fourthly, understand the accessibility requirements. Pull boxes must be readily accessible for inspection, maintenance, and future modifications. Fifthly, adhere to the National Electrical Code guidelines. Always comply with the sizing requirements outlined in the National Electrical Code to ensure electrical safety and code compliance. Let's further clarify some critical aspects related to pull box sizing and installation. First aspect is straight pulls versus angle pulls. Straight pulls involve conductors entering and exiting the pull box in a straight line, while angle pulls involve conductors changing direction within the pull box. Angle pulls generally require larger pull boxes due to increased bending space requirements. The second aspect is conductor fill calculations. Accurately calculate the conductor fill of the pull box to ensure that it does not exceed the maximum allowable fill percentage specified in the National Electrical Code. The third aspect is bonding and grounding. Ensure proper bonding and grounding of the pull box and associated equipment to maintain electrical safety and prevent ground faults. The fourth aspect is labeling and identification. Clearly label and identify all conductors within the pull box to facilitate troubleshooting and future maintenance. The fifth aspect is environmental considerations. Consider environmental factors such as temperature, humidity, and corrosive elements when selecting pull box materials and installation methods. Now, let's elaborate on the practical considerations for pull box installation. 1. Planning and layout. Before starting the installation, carefully plan the layout of the pull box, conduits, and conductors to ensure proper fit and accessibility. 2. Material selection. Choose pull box materials that are suitable for the environment and application, such as steel, aluminum, or non-metallic materials. 3. Proper support. Ensure that the pull box is adequately supported to prevent stress on the conduits and conductors. 4. Sealing and weatherproofing. Seal and weatherproof the pull box to prevent moisture and contaminants from entering and damaging the electrical connections. 5. Inspection and testing. After installation, thoroughly inspect and test the pull box to ensure that it meets all applicable codes and standards. In addition to the above, it is important to understand the relevant articles and tables in the 2020 National Electrical Code concerning pull box sizing and installation. Firstly, Article 314.16, which covers the minimum dimensions of pull boxes, junction boxes, and handheld enclosures. Secondly, Table 314.16a, which provides the minimum dimensions for pull boxes based on the size of raceways and conductors. Thirdly, Table 314.16b, which provides the minimum dimensions for pull boxes containing angle or U-pulls. Fourthly, Article 314.28, which covers the installation requirements for pull boxes, junction boxes, and handheld enclosures. Fifthly, Article 314.29, which covers the support requirements for pull boxes, junction boxes, and handheld enclosures. Furthermore, let's examine common mistakes to avoid during pull box sizing and installation. 1. Undersized pull boxes. Avoid using pull boxes that are too small for the number and size of conductors, as this can lead to overheating and insulation damage. 2. Exceeding conductor fill. Do not exceed the maximum allowable conductor fill percentage specified in the National Electrical Code, as this can cause overcrowding and difficulty in making connections. 3. Improper bending radii. Ensure that conductors are bent with the proper bending radii to prevent damage and maintain insulation integrity. 4. Neglecting bonding and grounding. Do not neglect to properly bond and ground the pull box and associated equipment, as this can create a shock hazard. 5. Inadequate support. Avoid using inadequate support for the pull box, as this can lead to stress on the conduits and conductors. Now, let's consider specific scenarios and examples to illustrate pull box sizing principles. Scenario 1. A pull box is used to transition between two different sizes of conduit. In this case, the pull box must be sized to accommodate the larger conduit. Scenario 2. A pull box is used to make a 90-degree bend in a conduit run. In this case, the pull box must be sized to provide adequate bending space for the conductors. Scenario 3. A pull box is used to splice conductors. In this case, the pull box must be sized to accommodate the splices and provide adequate working space. Scenario 4. A pull box is used to terminate conductors. In this case, the pull box must be sized to accommodate the terminations and provide adequate working space. Scenario 5. A pull box is used in a hazardous location. In this case, the pull box must be listed for use in hazardous locations and installed according to the requirements of the National Electrical Code. Continuing our discussion, it's crucial to understand the different types of pull boxes available and their applications. Firstly, metallic pull boxes. These are typically made of steel or aluminum and are used in a wide range of applications, including commercial and industrial settings. Secondly, non-metallic pull boxes. These are typically made of PVC or fiberglass and are used in corrosive environments or where electrical isolation is required. Thirdly, weatherproof pull boxes. These are designed to protect electrical connections from moisture, dust, and other environmental factors and are used in outdoor or wet locations. Fourthly, explosion-proof pull boxes. These are designed to contain explosions and prevent them from spreading to surrounding areas and are used in hazardous locations where flammable gases or vapors are present. Fifthly, handheld pull boxes. These are smaller pull boxes that are typically installed at ground level and are used to provide access to underground conduits and cables. Let's now focus on best practices for conductor management within pull boxes. 1. Neatly arrange conductors. Arrange conductors neatly within the pull box to prevent tangling and make it easier to identify and access them. 2. Use cable ties or straps. Use cable ties or straps to bundle and secure conductors within the pull box, keeping them organized and preventing them from shifting. 3. Maintain proper bending radii. Ensure that conductors are bent with the proper bending radii to prevent damage and maintain insulation integrity. 4. Avoid overcrowding. Avoid overcrowding the pull box with too many conductors, as this can make it difficult to work inside and can lead to overheating. 5. Label conductors clearly. Label conductors clearly with the circuit numbers or other identifying information to facilitate troubleshooting and future maintenance. Now let's consider the impact of voltage and current on pull box sizing. 1. Voltage considerations. High voltage systems may require larger pull boxes to provide adequate insulation and separation between conductors. 2. Current considerations. High current systems may require larger pull boxes to dissipate heat and prevent overheating. 3. Conductor ampacity. Ensure that the conductors used in a pull box are sized appropriately for the intended current load to prevent overheating and insulation damage. 4. Derating factors. Apply derating factors to conductor ampacity when multiple conductors are installed in the same pull box to account for heat buildup. 5. Overcurrent protection. Provide overcurrent protection for conductors within the pull box to protect against short circuits and overloads. Moreover, let's discuss the role of grounding and bonding in pull box installations. 1. Equipment grounding. Ensure that the pull box itself is properly grounded to provide a path for fault currents and prevent electrical shock. 2. Conductor bonding. Bond all metal components within the pull box together to create a lower impedance path for fault current. 3. Grounding electrode conductor. Connect the pull box to a grounding electrode conductor to provide a connection to earth ground. 4. Grounding bushings. Use grounding bushings on conduit entries to ensure secure and reliable ground connection. 5. Grounding jumpers. Use grounding jumpers to bond together sections of metal conduit or equipment that are not otherwise connected. In addition to the above, it is important to consider the specific requirements of the authority having jurisdiction, which is your local electrical inspector. 1. Local amendments. Be aware of any local amendments to the National Electrical Code that may affect pull box sizing and installation requirements. 2. Permit requirements. Obtain the necessary permits before starting any electrical work, including pull box installations. 3. Inspection procedures. Follow the inspection procedures established by the authority having jurisdiction to ensure that your installation complies with all applicable codes and standards. 4. Inspector interpretations. Be prepared to discuss your installation with the electrical inspector and address any questions or concerns they may have. 5. Documentation requirements. Maintain accurate documentation of your installation, including drawings, specifications, and inspection reports to demonstrate compliance with code requirements. Furthermore, let's explore advanced topics related to pull box design and installation. 1. Finite element analysis. Use finite element analysis to model the thermal and mechanical performance of pull boxes under various loading conditions. 2. Computational fluid dynamics. Use computational fluid dynamics to simulate airflow and heat transfer within pull boxes to optimize cooling and prevent overheating. 3. Advanced materials. Explore the use of advanced materials, such as carbon fiber composites, to reduce the weight and improve the strength of pull boxes. 4. Smart pull boxes. Incorporate sensors and communication technology into pull boxes to monitor temperature, humidity, and other environmental factors and provide real-time alerts of potential problems. 5. Modular pull box systems. Utilize modular pull box systems that can be easily configured and reconfigured to meet changing needs. Let's now delve into the future trends in pull box technology and design. 1. Miniaturization. Expect to see smaller and more compact pull boxes that can be installed in tight spaces. 2. Integration. Expect to see greater integration of pull boxes with other electrical equipment, such as switchgear and control panels. 3. Wireless technology. Expect to see pull boxes that incorporate wireless technology for remote monitoring and control. 4. Artificial intelligence. Expect to see pull boxes that use artificial intelligence to predict and prevent failures. 5. Sustainability. Expect to see pull boxes that are made from sustainable materials and designed to minimize environmental impact. In conclusion, understanding pull box sizing rules and best practices is essential for ensuring electrical safety and code compliance. By following the guidelines outlined in the National Electrical Code and consulting with your local electrical inspector, you can ensure that your pull box installations are safe, reliable, and efficient. Remember to always prioritize safety and consult with qualified professionals when working with electrical systems. This information serves as a general guide and should not be considered a substitute for professional advice. Always consult with a licensed electrician or electrical engineer for specific applications. Proper pull box sizing and installation are critical for the safe and reliable operation of electrical systems. By adhering to the guidelines and best practices discussed, you can minimize the risk of electrical hazards and ensure compliance with applicable codes and standards. This comprehensive overview provides a solid foundation for understanding pull box sizing and installation. Remember to stay updated on the latest codes and standards and consult with qualified professionals for specific applications. The correct application of these principles ensures safe and efficient electrical installations. Now, it is important to remember that the information provided here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a licensed electrician or electrical engineer for specific applications and to ensure compliance with local codes and regulations. Electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from electrical hazards. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and following safe work practices. By prioritizing safety and seeking professional guidance when needed, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and standards. Remember that electrical codes and standards are constantly evolving, so it is important to stay updated on the latest changes and interpretations. This can be achieved by attending training courses, reading industry publications, and consulting with experienced professionals. By staying informed and continuously improving your knowledge and skills, you can ensure that you are providing the best possible service to your clients and protecting the safety of yourself and others. Finally, remember that electrical work is a complex and challenging field that requires a high level of knowledge and skill. If you are not comfortable performing electrical work yourself, it is always best to hire a qualified electrician or electrical engineer to do the job. This will ensure that the work is done safely, correctly, and in compliance with all applicable codes and standards.